Okay, so we're trying to figure out how many steps on average it takes from getting, after you get the first coupon, how long does it take you to get the second coupon on average? So we know that 4/5 of the time it's going to take one.
It's a bit of a series after this.
Okay, so how can we write down the probability that it's going to take 2?
Well, you can do 1/5 times 4/5.
All right, 1/5 times 4/5. It takes 2. And what about the probability that it takes 3?
1/5 times 1/5 times 4/5.
It takes 3.
And this is a geometric series we can calculate the sum of.
Not quite, actually. It's a little more complicated than a geometric series because we're trying to count not the probabilities at each step, because those have to add up to 1.
Or
We're
the
trying to count
values.
the values. So we're evaluating 1 times 4/5,
Yeah.
2 times 1/5 times 4/5, 3 times 1/5 times 1/5 times 4/5. Sorry, I'm just trying to stay on the screen here. So it's a little bit more complicated than a geometric series, but not a lot more complicated. And maybe it actually is something that we can sum. So we got 4/5 times 1 plus 1/5 times 4/5 times 2 plus 1/5 times 1/5 times 4/5 times 3. Dot, dot, dot. All right. Do you have any sense on how we might sum this up?
Well, I think we can at least simplify it a little bit by just factoring out 4/5 out of everything.
Okay. Yeah. Great. So this is 4/5 times 1 plus
2/5.
1/5 times 2 plus 1/5 times 1/5 times 3 plus 1/5 times 1/5 times 1/5 times 4. Okay, yeah, that was a good first step.
So it's kind of annoying because the bottom of our fractions are geometric series, but the top is an arithmetic series.
Yes, that is exactly kind of the problem here. So maybe we can actually even just focus on the inside and at the end multiply by 4/5.
Yes.
So so 1 plus 2/5 plus 3 25ths plus 4 over 125. Dot dot dot. Well, we know the terms are going to go to 0 pretty quickly.
Okay, yeah, the terms go to 0
So
and fast.
we could just like chop off the sequence, like stop it at maybe 1/5 times or the next term, because by then the terms are going to be so small that it's not going to make a huge difference.
Okay, yeah, so that's not a terrible idea. Let's just see. Maybe we can even just stop it here and see.
So 4 over 125.
So we get 1 plus 2 divided by 5 plus 3 divided by 25 plus 4 divided by 125. Plus we could do the next one. The next one's actually easy. What is the next one?
5 over 625.
So
1
1 over
one.
125.
Plus 1 divided by 125. Okay, so that's 1.56, and then times 4/5. 4 divided by 5. So we get about, we know this is about 1.248 so far.
It's going to be a little larger than what we thought of our original guess of 6/5.
Oh, good point. So your original guess of 6/5 was equal to 1.2, so it is a little bit larger than that.
Maybe it's 1.25.
Okay, so
Maybe it goes to 1.25.
maybe this goes to 1.25. Okay. So now we have a revised guess. What is 1.25 as a fraction?
It's 5/4.
5/4. Okay. So now we're back to trying to figure out if we can. We think this whole thing on the inside times 4/5 might be 5/4. So what can we do to sum this? This is a challenging sum.
Well, we could maybe like first we could write this equal to be 5/4 and then multiply it by 4/5, or divide both sides by 4/5.
Oh yeah. If we sort of guess what it equals, then we could maybe manipulate it. But let's try to start from the beginning.
We could do
just on
something
the inside.
similar to that, where we set the inside equal to x, and then maybe we multiply by something, and then subtract away from the original sum.
Okay.
Yeah.
So.
All right. Is that what you meant?
No, I was just
Okay.
trying to see if it was.
All right. Let's go. Let's do that in the next video.